Hi there, welcome to this lecture. In the previous lecture, I spoke about what happens when threads are sharing the same data, and I taught you how to synchronize threads so that if one thread is running a piece of code, no other thread can interleave into that if the synchronized keyword is being used, right? The other threads would have to wait until the code that's in the synchronized block is done executing. So the thread essentially acquires a lock on that piece of code so that no other thread can interleave. Similarly, I'm going to continue on that discussion, but we're going to talk about what happens when a collection of data is being used by multiple threads. So let's say we have a list that needs to be inserted data into, and one thread is inserting data into that list, whereas another thread is trying to read that data simultaneously. Right? One thread is writing, the other one is reading from that list. What can happen? And we're going to talk about the concurrent modification exception that can occur. And I'll explain to you how to handle those sorts of situations when two threads are dealing with a list, the same list of data at the same time. So to go over this topic, I've created a project here called Threading Inventory Manager. And the use case that we're imagining here is an inventory management system where we have products that are being sold, on our website, for example. So we'll have a product purchased list and we'll have a product sold list. And we're going to share those lists across multiple threads so you can see the kind of problems that can happen. So that's the name of this project, Threading Inventory Manager. So I'm going to right click here on the project and go to New, Class. And this is going to be the product class. All right, this class is going to represent any given product that we have in our inventory. And the package, you can just state right here, it's going to go in com.jobready.inventory. Okay, so this is the same naming convention that we've been using, and just hit finish. All right, so notice it created the package and it dumped the class in there. This class is going to be very simple. I'm just going to have an ID field, and I'm going to have a name field that is of type string. And let's just create a constructor. I'm going to right click and go to source and generate constructor using fields, and just hit OK. And that's our constructor. And then I'm also going to have a toString method, which I've copied here off screen. I'm just going to paste it right here. And notice that it's just going to have the ID and the name that's printed, and separating those two with a pipe symbol. So that's quick and easy. Let's close that file. The next class I'm going to make is also going to be in the inventory package. So just go to New, Class, and this is going to be called the Inventory Manager. And this is just going to be a utility that allows us to add products to our sold product list and then display those products. So I'm going to define a list here that is of type product, right? The object that we just created, and we'll call it sold products list is equal to new array list, and it's of course of type product. And there we go. Let's just do the import, do the Control-Shift-O, and we're going to go to the util list. So that's our sold products list. I'm just going to go ahead and create another list, and this is going to be called purchased products list. And this is also going to be an array list of type product. So now we have two collections, the sold product list and the purchased product list. And the next thing I'm going to do is just create a utility method that just populates sold product list. Okay, it's just going to populate this list with some sample or test data, all right, test products. And that's just going to be called, it's going to be a public void method, and it's going to be called populate sold products. And inside it's just going to be a for loop. Int I is equal to 0 as long as I is less than 1,000. So we're going to try to insert 1,000 products in here. I++, and I'm just going to simulate adding products to this list. So let's just instantiate a product is equal to new product, and two arguments for this constructor. The first argument is the ID, and the second argument is going to be the name of the product. So we're just going to call it test underscore product underscore, and then I'm going to append the I variable, which is going to be the from 0 to 999. So the ID is also going to be the part of the product name. And then after that product is instantiated, I'm just going to add it to the sold products list. So we could just call the add method and just give that object there to populate in that list. And after that's been added, I'm also going to print out a statement. We'll just call it added. That's going to state the particular product that was added. Okay, let's just put a space between this word and the actual product. And the actual object name is actually prod, so make sure you spell that correctly. Just so that this loop doesn't execute immediately, right? 1,000 things to add in a list is going to run very fast. So I'm just going to make it a little bit more realistic. And let's say we're, getting these product details from a database or something, and we're inserting into this list. So that may take a couple of seconds. So I'm going to put a thread.sleep method and specify, 10 milliseconds. Just so that it doesn't populate the list instantaneously. And this is to prove a point for threads interleaving. That's why I'm adding this sleep, otherwise it's completely unnecessary. But I want to demonstrate to you what happens when two threads are trying to access the same list at the same time. That's why I'm making each insertion, I'm slowing down each insertion. So this throws a interrupted exception, so I'm just going to surround it with a try catch block. So this method is a utility method that populates this sold product list. Now I'm also going to have a method called display sold products. So we'll just call it public void display sold products. And what this method is going to do is going to iterate over this sold products list and print the contents of that list. So it's going to be a for each loop. The type of the data is called product, and this is the actual product in that list of sold products list. And then I'm just going to system.println and I'm just going to type sold, okay, and specify the particular product that was sold. Let me just add printing the sold product, because that's what this method does. It's just going to display the sold products. Now, just so that all the products don't get displayed immediately, right, it can iterate through this list very fast. It's only 1,000 items. I'm going to do a thread.sleep in here as well. Thread.sleep. And we're going to just sleep it for 10 milliseconds, which I think is 100th of a second. And we're going to surround this with a try catch as well. Let's just get rid of those comments. And there we go. So right now I'm only utilizing this sold products list. This purchase products list, we're not going to do anything with it just yet. So let's just leave that alone for now. The next thing I'm going to do is create another class. So I'm going to right click and go to new class, and this is going to be our application class, which is going to have the main method, right? This is going to be the starting point for this application. And just so that we have a different package, instead of it going to the inventory package, I'm just going to have a package called client and just hit finish. So this class is created in the client package. So in here, I'm just going to create an instance of the inventory manager, and we'll just call it manager is equal to new inventory manager, and do the Control-Shift-O to bring in that import. And now using this manager, I can invoke the populate sold products, right, to populate all of the test products into this sold product list, or I can also use that manager to display the sold products. So I'm actually going to invoke both of these methods, but I'm going to do it in two different threads so that you can see that when this particular list is being utilized by two different threads, what happens, okay? So again, I'm going to create a thread here that's going to invoke the first, populate product list. So for that, I'm just going to create a thread. We'll call it inventory task is equal to new thread. And as an argument to this thread constructor, it's going to be a new runnable, right? So we're doing it in an anonymous class type way. And in here, it's going to ask us to implement the runnable method, right? So let's just add unimplemented methods. And in here, I'm just going to use manager dot populate sold products. Okay, so this is one thread. This is going to populate the sold products. So I'm going to create another thread. Let me just copy this code right here. And instead of this inventory task, this is going to be called display task. And this is going to display those populated products. So I could just do manager.display sold products. All right, so we got one thread populating those products. The other thread is going to be displaying what's been populated. So both threads are going to be simultaneously accessing this particular sold products list. All right, I want you to pay attention to what happens when both of these threads accesses that list. So let's kickstart these threads. I'm going to do inventory task.start. All right, that's the first thread. And then after that, I'm going to launch the second thread. It's going to be display task.start. So up to this point, as you're aware, it takes time for a thread to launch, or to spawn rather, right? So once this line is executing, once that thread is starting, right, it may not even have inserted any data into that list, and this display task may already be complete, right? Because there's nothing in that list to display, and so this might run fairly quickly, and it may not display anything at all because that list may be empty by the time the main thread gets to this line, right? Because again, the main thread, what does it do? It runs line by line, just like any other thread. It comes here and says inventory task, start yourself. So this task is going to get started, and then it'll immediately move to the next line, and this guy is going to just print whatever's in that list, and that list may not have anything in there because this thread may just be starting at that point. So to make sure that there is something in that list when this display task is started, I'm just gonna use the thread.sleep method here as well, and let's just sleep for 2,000 milliseconds, which is about 2 seconds, just so that within 2 seconds we should have some data in this sold products list. Okay, and again, this is going to ask me to surround with try catch. Since this is the main method, I'm just going to keep things simple, and I'm going to add throws declaration so that this interrupted exception is thrown from the main method. All right. So I want you to see what happens when I hit the play button. Let's hit play. And I don't know if you saw that, but while it was printing, there was a red line that was printed. So all the way to the bottom, let's just scroll down. Notice it's printing all of the products. It's writing that added. So right now, up to this point, it's fine. The first thread is finally complete, and it printed all of the products. So that's this method right here. Populate sold products is running, so it's inserting the data into this sold products list. Okay, so that's this inventory task that's completed, but then the display task, right? We don't see anything displayed. What do we expect this task to print? This task should be printing, this sentence right here, printing the sold product or whatever. Okay, so I don't see any printing here. I just see added. Let's scroll up, and all there is added. So it never really got to that point. And when it tried to, notice we got one printing. We've got one line that printed, and notice that it said a concurrent modification exception. So this exception is saying that you cannot access a list that is being modified. So this method right here is modifying the sold product list, but while that's going on, another thread comes in and tries to read what's in that list, right? Iterate over that list and try to print out the contents of that list. It's not allowing that, right? So these collections, that should show you that these collections are not thread safe. The array list, the hash set, the hash map that you've been seeing, these are some of the collection framework classes. They're actually not thread safe out of the box. You'd have to involve the synchronized keyword in your code to prevent this sort of thing from happening, right? We went over the synchronized block in the previous lesson. So that's one way of doing it. Another way is here in the main thread, I could just have thread.sleep to 20 seconds. And this is a very primitive way of doing it, because this is just going to hold. All right, it's going to sleep while this thread is running. All right, and by then, in about 20 seconds, we should have all the data populated in through this inventory task. And so then display task will be able to run, because by then the list will stop being modified, right? It'll be done, so we'll be able to access it. But this is, again, a very primitive way of doing it. An alternative is something called the join method. We could do inventory task dot join. And what this is going to do is it's going to basically wait here on this line until inventory task is completed. So you might be wondering, what do you mean by join? Why is it called join and not pause or something? Well, the reason is this join means joining the main thread. The main thread, right, that's the first thread that gets launched by the JVM. That's the guy that calls this main method. So everything in this main method is being executed line by line, right, by the main thread. And when it gets to here, it's basically saying to the main thread to hold your horses until the inventory task joins you, okay? It joins the main thread. And by that, what they mean is until this is completed. So until this is completed, it's not going to move on. It's going to wait till the inventory task thread joins the main thread, and only then it's going to proceed to the next line. So now, as you can probably imagine, this is more sequential, right? This is really not multi-threaded in any way. We won't have two threads really running at the same time if we use this approach, right? Inventory task will run, but then this guy is not going to run until inventory task is complete. So it's quite sequential in a way, right? This is not multi-threaded. Let me run this, and you'll see that we won't see the printing sentence here until this inventory task is complete. So there we go. This is about to complete, and there you go. We see printing now after the first task has been completed, right? After this adding of inventory has been completed, only then the printing begins. So this is not multi-threaded. Because of this join, we couldn't proceed to the next line. The main thread waited for the inventory task to join before it told this thread to start. So sleeping the thread or using this join, both of these approaches don't really solve the problem, right? The problem is we want to be able to access the collection, right? We want to be able to access a sold product list from two different threads simultaneously. How do we do that? The array list is not thread safe out of the box. And the reason why the Java community decided to not make this thread safe is because it would slow things down. In Java 1, threading was introduced, and there was a list structure called a vector. Let's just create an instance of the vector class, just so that we can do the Control-Shift-O to bring in the import, just so that we can browse this class. Let's click on this vector, Control-click, and then search for the word synchronized. And you'll see all of these methods, set size, capacity, size, is empty, all of these methods, index of, these are all synchronized methods, okay? So that means they're inherently thread safe. Even adding and removing elements, it's all synchronized. Whereas if you were to look into the ArrayList class, do a control click on ArrayList and then do a search for the word synchronized, click on find, and you'll notice that it's only shown in the comments. It's actually not shown, it's not being used in the method signatures, right? So this list is not synchronized, meaning it's not thread safe. So we can't use the array list for multi-threading. We'd have to introduce synchronization in our code, or there is another alternative. You could use what is known as a concurrent collection. Concurrent collections were introduced, I believe, in Java version 5. And they're meant to be thread safe because all of the methods in those collections are actually synchronized. And there are a handful of these concurrent collections, and they belong in the concurrent package, which we'll look into in just a second. But you can go on the Oracle website. They have a great tutorial on the Java concurrent collections. So look into that whenever you get a chance. But we're going to be exploring a concurrent collection in this lecture known as the copy on write array list, which works very similar to the array list, except the methods in this concurrent version are all synchronized. So let's actually use that. I'm going to change this array list to the copy on write array list. That's called copy on write array list. And do a Control-Shift-O to bring in the import, and you'll notice that this list is coming from the java.util.concurrent package. Okay, so in your multi-threaded programs, when you have a collection of data, make sure that you're using the collections from the concurrent package, not from the regular util.list. So this works essentially the same way as an array list, except if you go into the body of this method and you search for the word synchronized, you'll notice that it's being used for adding data, it's being used, and for removing data, it's being used everywhere in this class. So this class is certainly a thread safe collection. So when you have a collection of data and it needs to be accessed by two threads, make sure you're using the collections from the java.util.concurrent package, not the java.util package, okay? And there are a handful of these kind of collections, so whenever you get a chance, toward the end of the course, make sure you look these up and figure out some of the alternatives that you have. They work exactly the same way as some of the collections that you've already seen, but they have the added benefit of thread safety. But for this example, we'll stick with this copy on write array list. And now, going back to this application, I'm still going to need the thread.sleep here just so that we populate some data. Let's just sleep for 2000 milliseconds, so 2 seconds, just so that we have some data populated by this inventory task. We're going to sleep, and then this thread is going to start, which means at that point, we're going to have the inventory task as well as the display task operating on the same collection at the same time, running simultaneously. One thread is going to be writing, the other one is trying to read that list. So let's hit play. And there you go. Notice that it started printing and adding at the same time. Okay, so while this is being added, while that list is being modified, it's printing as well. So that's perfect. It's working as expected. We were able to access that copy on write array list simultaneously from two threads. Now notice the printing will stop after 100 or so products. And the reason for this is while the main thread was sleeping for 2 seconds, the inventory task was running behind the scenes, right? So that was loading data into that collection, into that copy on write array list. And then once the main thread was done sleeping, it proceeded to the display task and told that one to start. And by then, there was some data in that copy on write array list. Now, all of the data was not loaded up to that point, right? Whatever it could load in that 2 second time frame, the inventory task was running for an extra 2 seconds before the display task was told to display the data. So 100 or 200, however many products made their way into that list are displayable using that display task, but not more than that, because that's all it's able to read from that list. So again, before wrapping up, just a quick review. Watch out for that concurrent modification exception. When a list or a collection is being shared across two threads, make sure to use the concurrent collections, not the regular array list or hash set. And we also spoke about that thread.join method, which basically tells the main thread or whichever thread to join before proceeding to the next line, okay? So using thread.join or thread.sleep are primitive ways of controlling the flow of threads in your program, and use them sparingly. These are bits and pieces that are good to know about, but these lower level methods are not meant to be used for managing thread execution. Java provides some other mechanisms for managing thread execution known as the executor framework with thread pools. So we're going to look at that coming up. Before that, we're going to talk about a very popular pattern known as the producer-consumer pattern, which is pretty much ubiquitous in the world of multi-threaded applications. And you're going to learn how that works, and then we're going to move on to the executor framework with thread pools. So stay tuned. We got a lot to cover. Thanks for watching. I'll see you soon.